exam maths is a lot to do with knowing exactly what's on the syllabus. So when you see an integration question, you should have just immediately know it's one of these three things for sure. There's nothing else it could be. And so you say, right, is it on the formula book? Is it nearly on the formula book? If it isn't, then it's an integration by substitution question. Let's have a look at the formula book. It's just there, slightly annoyingly. This top one is in the standard level section of the formula book, and the rest are in the higher level section. So we can do a question like this one very easily. Obviously, you know that this is x to the minus 2. We can just add 1 to the power, x to the minus 1, and then divide by the new power. So I would say that is x to the minus 1 divided by minus 1 dx. Dividing by minus 1 is the same as multiplying by minus 1. And x to the minus 1, oops, sorry, didn't mean dx. X to the minus 1 is just 1 over x. So that's straight off the formula book. Notice the standard level says this doesn't work for x squared. So if we have this question, so many students will just go to this top one and try and add 1 to the power, and it's all a disaster. Obviously, it's this one here. It's just log x. So when it says formula book, it doesn't mean it's literally directly on the formula book. It could be a slightly harder question like this. And when you look at this, you say, is it on the formula book? Obviously not. So you then immediately move down the checklist. But it is on the formula book, because I can write that as x over x plus 1 over x. And that is the integral of 1 plus 1 over x. And those are both on the formula book. The integral of 1 is x. The integral of 1 over x is log x. So be a little bit careful there. Similarly, if you had a question like x times x plus 3 or something, integrate that, and you may feel, ooh, this looks a bit like an integration substitution by substitution question. That would actually work. But it's so much easier if you just say, I'm just going to multiply that out. And then we can just integrate straight off the formula book. So be careful when you say, is it on the formula book? However, some things are nearly on the formula book. Let's take this, say cos x1. The integral of cos x is on the formula book. What about 2x plus 3? And you say, oh, that's a near miss. Now, if it's a near miss, in the sense that the thing replacing the x is linear, in other words, ax plus b, if that's what I mean by nearly, is it nearly on the formula book? So only if it's linear, then we can just treat it as though it's on the formula book. So the integral of cos of something is, there it is on the formula book, it's just sine of the same thing. And you treat it as though it's on the formula book like that, but then you must remember you simply divide by that number. Okay, so this is, in fact, a shortcut of integration by substitution. You could do the full integration by substitution method, but these come up all the time. And it's so much easier if you just remember this little trick. So let's do another one of those. And it's the most common one of the lot, which is something like 7 over 2x plus 1 dx. So you say to yourself, is that in the formula book? No. Is it a linear version? Well, it is, because it's this one. The 7 is a bit annoying, though, because that is clearly not on the top of the fraction. However, multiplying constants can come in and out. I'm going to just move that 7 out. Now I have a full-on linear substitute, so I can write the answer down. I'll leave that 7. Now, the integral of 1 over something is log of that thing. And now what do I have to do? Say it to yourself out loud. Divide by 2. Boom. And so that is nearly formula book. So here's the checklist. Is it directly on the formula book? No. Is it nearly on the formula book? No. So then the only other thing on the syllabus is substitution. And that one is a very straightforward method. You say u equals, and you have to decide the substitute, but it's always the thing that's in brackets, the thing that's in the center of the question. In this case, I think very clearly x squared plus 3. Another way of testing the substitute to see if you've got it right is you differentiate it, which is part of the method anyway. And we get 2x, and you say to yourself, will this x here, will that cancel with anything? And that is a sign you've done it right if the answer is yes. This x here has got a chance of cancelling with that. And so you think, I'm on the right track here. So you differentiate, you rearrange it so that it reads dx. I'm going to multiply, so I'll do a cross multiply here, where I multiply the dx up. Sorry, that's a du there. Multiply the dx up and divide the x down. And the 2. What am I doing? So you rearrange it until it reads dx equals. And what we're going to do is replace everything that we can in this original integral. So this is an integral. That x has not changed. That one is still sitting there. E to the power, now that is u. And the dx has now gone. That is du over 2x. And as expected, and will always happen, the x's cancel. I'm going to take this half out of the integral, and I'm finally left with a lovely, easy integral. And this will always happen. So what I've done is convert a difficult x integral here into an easy u integral there. So this final integral must only have u's in it, and the original question only has x's in it. So I then can just integrate that. When I integrate e to the u, I get e to the u, but u is equal to x squared plus 3. And so that is integration by substitution. It never changes. It's pretty straightforward. And just lastly, there's one last little trick that's worth remembering. So we've got formula book. We've got a near miss formula book. We've got substitution. But just here, if you remember one little trick saying, is there anything that looks like f dash over f? So anything that looks like that? For example, the integral of 2x over x squared plus 1, that is exactly f dashed over f. Well, if you want, you can just simply write the answer down. It's log of the bottom. And that is a nice little trick. So the integral of f dashed over f is log of f. Let me do one of those. It's a little bit harder. You've got the integral of 3x over 2x squared minus 7. Now you can do integration by substitution on this question. No problem, just do it. But if you're feeling a little bit more advanced, you can say, oh, this is nearly f dashed over f. When I differentiate the bottom, I get 4x. Unfortunately, I've got 3x, but that's so close. So what I'm going to do is I'm going to take that 3 out like that. That's a distracting multiplying constant. Take it out. When I differentiate the bottom, I get 4x. So I'm going to write that in. I'm just going to force it in there. 4. I've multiplied this question by 4, so I will divide by 4. And now I can write the answer down without showing any other working. It's 3/4 of, this is exactly f dashed over f. So I can write log of the bottom. So that's a nice little trick. You don't have to use it. You could just say, in this question here, u equals 2x squared minus 7. If you like, and do all of integration by substitution. It's not very long. So you're not saving yourself much if you know this little trick. That's it.